We would also learn how to control the flow in our solidity, how to make use of our logic, because in writing smart contracts, logic is very important. When you are writing your functions, when you are writing your variables, your logic matters. It determines works and how your solidity flows. So we'll be taking a close look into that. We'll also take a look into error handling. Once you encounter errors, if you want to throw errors, we'll take a deep look into that also. Now, the first thing we're going to look at is the control flow. What is control flow? Now, this refers to the order in which the individual statements, instructions, or commands of a program are executed or evaluated. It represents the direction or sequence of execution within a program's code, right? So this actually shows at what point do you call your functions? From where does Solidity read? Does it read from line to line or from function to function? So all this refers to like the control flow in your Solidity. The particular order in which your Solidity code runs and works. That's what we
Hello, sorry,
that's
is it
what
me or the
control
voice is
flow
cracking?
means. Now,
Can,
so you said my voice is
hello, if you
what?
can join, please can you send an emoji? It's cracking. We can't hear you very well.
Oh. Let me switch network.
Okay. If you can join very well, please send an emoji. If you can join very well, send an emoji, please.
Okay, can you hear me now? Is it better? Hello? Hello? All right,
Hello?
so we'll just continue.
Yes, you can move on.
Okay, so in terms of control flow, we need to understand that the control flow is managed through the logic statements where we have this conditional statements. Now, in your logic statement, this is where you make decisions. In decisions, in what sense? Now, when you are making decisions, even in the real life scenario, there are certain decisions you make based on conditions. So that is, for example, you wake up today and then you would ask yourself, is the weather cold? If the weather is cold, wear a sweater, right? If it's not cold, wear something not heavy, right, to withstand the sun. Now, that is you making decisions based on conditions. Likewise, in your Solidity code, you would make decisions based on conditions. That's why we have statements like if, else. We also have the switch case in Solidity. Now, all this helps in your logic statement. Now, when we're talking about logic, you need to understand that we're talking about okay, to come back to the explanation of logic. Another structure we'll be taking a look at is what looping. Looping is we'll still look at that later on. And then lastly, we'll be looking at function calls, that is your method invocation. Where do you call your functions? If you write a function, at what point do you call it? Where in particular do you call your function? Now, all this makes up for our control flow structures. So they all determine the order in which your contract runs and works. Now, the first structure is logic. This involves evaluating conditions or expressions to determine whether they are true or false. Conditions are often used to make decisions and control the flow of a program. Now, when you're writing your logic and you're trying to evaluate a condition or expression, you need to evaluate it to a Boolean. What do I mean by a Boolean? That is, you need to evaluate it to a true or false uh, answer. Now, what do I mean? When you are in the real life sense, when you're asking yourself the questions of should I do this, should I do not do this not, you answer yourself using booleans. That is, for example, you say, should I eat? Yeah, and the answer is true or false. You're going to answer yourself yes or no, which in a sense is actually true or false. So likewise, when you are writing your logic, you need to evaluate them to true or false. Right? Is this number greater than zero? If it is true, do this. Is this number less than two? If it is true, do this. If it's false, do something else instead. Now that is what we mean by logic. And you need to really take your time to understand logic, because in the business wise, when you are building for business, it is a must that logic will be involved. Even if you are building for a particular product, if you are building a smart contract for your product or for any project, you must make use of logic at some point. You would make use of logic for user permissions. Is this user an admin? Is this user just a normal user? You would make use of it at every point, even in your programming journey. Now, as I've said, conditions are often used to make decisions. So before you make a decision, you're allowed to evaluate the condition to true or false. And then from there, you can control the flow of a program. So your flow can have, so your program, your contract can have multiple flows depending on the conditions. And that's it for logic. Now, we have the if-else statements in logic. This is like a simple example of the statement. This is how it looks like. I remember, I think I showed something like this last week in one of our classes. So use the keyword of if, and then inside of your parentheses, that is your bracket, you input in the condition. If you want to check if a variable is greater than zero, what you do is, instead of this syntax, you type in if, then inside of the bracket, you type in the name of the variable. Let's say if the variable is amount, the variable name is amount. Inside of the syntax, you say if amount is greater than zero. So you use the greater than sign to represent greater than, and then you put that instead of the condition. Now, take note of this. When the amount is greater than zero, the code between your curly braces, that is, notice there is another type of bracket after the conditional statement. Now we call that the curly braces. Now the code inside of it is going to run once your condition evaluates to true. If your condition doesn't evaluate to true, the next statement is going to run. So if you add an else if is also used to, just like what the word means, else if the condition, if your first condition is false, the next thing that's going to run is your else if. And then you can, inside of your else if, you can add another condition. So for example, if you want to check for, probably you want to check you are trying to check for two conditions. And then you check, okay, if age is greater than 18, that's going to be inside of your first if statement. And then you're now trying to check if, okay, since we don't have 18, do we have 16? So what you do is you come into your else if, and then inside of the condition, you will check if age is greater than 16. And then you can now run your code afterwards. What should it do if age is greater than 16? If none of those conditions works, or it all evaluates to false, then your else statement is going to run. So it's actually quite simple. the keywords actually make it explanatory. So you just need to understand the flow of your if else statements. I'll just iterate through that again. Your if statement is used to evaluate conditions. If the condition is false, then you can make use of your else if. Those you need to note that your else if and else are optional. You can make use of them, you can decide to not make use of them. And then your else if is also used if your first condition fails or your any condition above your else if fails, then your else if is going to run. And then if it also fails, your else is going to run. That's your else is going to run. So that's just how if statement works. We would still look. I'm sure our team lead is going to do justice to the practical aspect of this. Now, the second point here is allow branching based on conditions. Using if else statement, you can now branch your code into different flows based on the condition, and that's how control flow works in Solidity. Okay, so we have what we call ternary operator. Those of us that are coming from JavaScript background, I'm sure we would know what ternary operator means. Now, it's just a shorthand for writing your if else statement. Now, in Solidity, the ternary operator is a concise way to write an if else statement in a single line of code. So note, if you are writing your longhand if statement, it can become bogus. That is, it can take multiple lines. Using your ternary operator, you can write your conditional statements in just one line. And then it works by taking three operands. So just note, it will take three operands. The first one is what? The condition to be evaluated. Now, this condition to be evaluated in your normal if statement, inside of your brackets, that's where you put the condition to be evaluated. But then here, your condition to be evaluated is going to be your first operand. And then the statement to execute if the condition is true. So note, in this syntax, you would see now in our syntax here, notice we have condition, and then after the condition, we have the question mark. And then we have statement one, and then after that, we have a column, and then statement two. What this syntax means and does is that if your condition is true, whatever you put in your statement one is going to run. And if your condition is false, whatever is after the column is going to run. So it is just basically your if else statement, but this time around in a short way, your shorthand way. Anywhere you see this code, I'll want you to note that it's called a ternary operator. This operator can help simplify code and makes it more readable by reducing the number of lines needed for conditional statements. Now, any questions so far on if else statements? There's no limit actually. So just huh? Okay, so there's no limit to how many. So you need to note your if statement can be one, and then your else if statements can be multiple. So you can have as much depending on the conditions that you have. So if you want to fulfill probably 10 conditions, you can actually use your else if statements multiple times. You can keep making use of that till it actually evaluates to true. In terms of efficiency, it actually depends. So the question most times you need to ask yourself is there a better way to do this? And then if you realize, okay, this is like the best way to manage this flow, then you can go ahead to make use of this. But then if you think about it and then realize maybe there's another flow, a shorter way to reduce your if and else if statements, then you can go ahead to make use of that. So it depends on what you're working on and if there's like a better flow to it by yourself. So it depends on you, the developer. Right. So that's it for if else statements. Another control flow structure we're looking at is loops. When we say loop, what does it mean? It means it's used to execute a block of code repeatedly until a specified condition is met. Now, let me give a real life example of what loops means and does. For example, if you have um, you want to ask 10 people, 10 of your friends, if one of them is holding your phone. What does that mean? It means for each of your friends, you are going to ask them, are you holding my phone? Meaning you have to ask 10 people, and meaning you are going to ask the question 10 times. No, it's not, you don't actually ask it 10 times. So you ask it till somebody says, yes, I'm with your phone. So if the fifth person says, yes, I'm with your phone, then at that point you're going to stop. Meaning you just asked 5 people, 5 persons. Now that's what loop does. The difference between if and loop is the fact that if just gets to evaluate like a single condition, but then in terms of you're trying to find something, you're trying to do something until the condition is met or until you find the particular result, you would keep doing the same thing. So that's what loop helps us to do. Loops are used to execute a block of code repeatedly. So until the condition is true, your code will keep repeating. So it's going to keep asking, but then it will move on to the next. You need to understand it to move on. It doesn't just ask the same person repeatedly. It's going to just, he asks this particular, out of your 10 friends, it's going to ask the first person. If the first person says no, it moves on to the second person. The second person says no, it moves on to the third person. And then from there, it repeats itself until the condition is met. Now, there are different flows and algorithms in loops. So it doesn't really necessarily mean you must ask one person or the other, but then that's like an advanced level. But you just need to understand that loops execute until a specific condition is met. Now we have what we call the for loop. What the for loop does is it executes a block of code a specified number of times. So just like I said, now for if statement, you use the keyword if. For the for loop, you use the keyword FOL. And then inside of your parentheses, you are going to pass in 3 parameters, right? So you would initialize your variable. And then the second one is your condition. You're going to pass in your condition as the second parameter. And then the third parameter is your increment or decrement. So this is where you're going to specify how do you want to increase. So for example, if you want to ask one by one after the other, inside of your increment or decrement, you're going to now specify your previous value plus one, that is I plus, let's say your variable name is I. You're going to specify I plus plus. If you want to jump to people, probably out of 10, you want to ask number one and then jump 2 persons. So meaning from number one, you're going to jump to number 3 instead of asking number 2. So inside of your increment, your third parameter, you're going to specify I plus plus, plus 2, right? So depending on how you want to structure your loop, there are scenarios where you want to start from the 10th person to the first person. What you do there is what you'd get. So what you do there is I minus minus. So you initialize your variable to the 10th person. You'll be like your variable is going to be equals to 10, and then from 10 you decrease it down to 1. So this is how your for loop works. So what's going to happen is inside of your code, it's going to run. So that's how loops work. Do we get? So notice whatever you initialize inside of your for loop, it can be accessed inside of your code. Now, when I talk about code, I'm talking about your curly whatever is inside your curly braces. So whatever is, so if you initialize your variable and then you give your variable the name of then inside of the code you can now decide to check, okay, if my condition is true, then return sin or something. All right, so now we'll be moving on to the while loop. Please, do you have any questions so far? Do we have any questions so far? Seems like there's no question. Those of us online, do we understand? Do you have any question? All right. Since no question, we'll move on to the next thing. Now, another loop is the while loop. So what happens is this while loop runs as long as the condition is true. What this means is if you have a variable counter and you initialize your variable to 0, that is your variable is equals to 0. If you want to make your, if you want to check or you want to run the code as far as your loop is less than 5, you can make use of your for loop. So as far as the condition is true, it's going to keep executing the code. So for example, so what you can now do is while counter is less than 5 inside of your condition, inside of your parentheses, you can now do something else. Probably the inside of your code, your curly braces, you can probably increment it. So what you do, so for example, it's just like how you write your if statement, but this time around using while keyword. So just like how the syntax for if statement is, that's how while is. But this time around, it's going the condition, the code is going to run as long as the condition is true. When it's no longer true, it's it stops running. Yeah, so that's how loops work. And please, I would want us to probably take this advice. Loops are a good thing, but there are scenarios where you can. There's what we call infinite loop, and in terms of infinite loops, is a scenario where your code keeps running infinitely. Does it have a stop time? Now, it's usually I think people that use while loop, especially people that use while loop, you have to be very careful of how you use it because there are scenarios where your code will keep running and then it never returns false. And so that means it will just keep running and running and running and running and running and running and running. And then in the end, your laptop would suffer for it. Because if you keep running the operation over and over and over, especially for a long period of time, and your laptop is not an iron, even for high-end laptops, there are scenarios where you would see laptops hanging. Because why? They have an infinite loop running. So you need to be cautious when you are writing your smart contracts. You need to be very, 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 very cautious that you're not running an infinite loop because it can be an omission can actually cause infinite loop. An omission that is you probably forgot to increment it or you just forgot like a syntax or something. It or just a line you just forgot to add the line of code. It can actually cause an infinite loop. And then even for your users, even if your laptop can handle it, if you end up deploying it and your users, it's going to affect their computers. So you need to understand and be careful of how you use your for loop. You need to make sure that at every point you have the condition where it's going to be false. That is, at a point, you are very sure your condition is going to stop at a certain point, and then you need to test it yourself. So you don't go and write infinite loops where, in the end, your laptop and everybody's going to suffer for it. So let's take note of that. All right. Now we'll be looking into error handling mechanisms. We have three statements that are used for error handling in Solidity. I'm sure we have seen our team lead make use of one or two. I think he even explained revert and require on Monday, or was it yesterday? Yeah, so most of this may not really look new to us again. So to understand this, we have the reverse statements. Our team lead showed us how reverse statement works. Now it is used to revert the transaction with an optional error message. So in here, you can use the reverse statement to revert a transaction where to throw an error for you. And then you have your require statement. Require statement actually used to check conditions. Most smart contracts you take a look at makes use of require statement. And that's because require statement is helpful. It's used for your input validation. What do you mean by input validation? Probably you are trying to check your if the address of the person trying to access the smart contract is that of the owner. So you can make use of that. Even our modifier where we check to where it runs before the function runs, you can make use of the require statement to check conditions. Now, if it can also be used, so it checks the condition and reverts the transaction with an error message if the condition is not met. So this is the syntax. You use the require keyword. For revert, use the revert keyword. And then in terms of require, you would have to pass in the condition first. And that condition must evaluate to true or false. Must be a true or false question. You cannot pass in just a string. Probably you have a variable that is probably initialize a variable to king, and then you just come in require, and then just pass in the variable name king like that. Now in that scenario, it might not work. So you need to check if king is equals to, if the variable king is equals to probably a string or something. So it must evaluate to true or false, and then you have the option to pass in the error message. You have the option to pass in the error message where it's if the condition is not met, it will revert the transaction with that error message. Now we have the assert statement, right? So it's used to check for internal errors and halt execution if conditions are not met, typically used for invariant checking. Yeah, so all of this would look deeply into them as our team lead takes on the practical section. All right, Mr. Oracle, you have the floor now. Please, do you have any questions so far?
GM, everyone. GM once again. If you have any question, please drop it um, on the message box. So, yeah. Okay, since there's no question, let's move on to the next thing. So the first thing I'll be doing is I'll be creating a new file. So I'll be naming the file donation.sol. Donation.sol. Let's get our boilerplate. So we have this smart contracts. Let me try to. Okay. So this is what we do. Let's create this contract. Name it donation. Yeah. So this contract is a very simple contract, and what it does is that it allows you to donate 5 Ether to these contracts. So anything lesser than 5 Ether or greater than 5 Ether is going to fail. And also, it allows admin to withdraw all the funds. There's going to be goals and every other thing so that we can understand how error handling works in Solidity. The first thing is, what is our goal for this? Let's make it immutable. So our goal is this. Then let's make it public so that we can access it off-chain. Public. And the next thing is, after the goal, we can have the progress. Public progress. So when you deploy the contracts, we need a constructor for that. When we deploy the contracts, we can have something like this in 256. Then the goal, so that we can set this goal that we are going to pass from off-chain to the goal in our state variable. So let's do that. Okay, that's all for now. The next thing is a method to deposit into this function. Let's name it deposit. And we are going to make it public. And we can also make it external here instead of public. Since we are not depositing from this contract itself, we can make it public. So the next thing is external payable. So now how do you now do the check-in? To do the check-in, we have to check using if statement, if message.value, which is the amount the person is depositing, is equal to 5 Ether. So this is, you can do something like this. Okay, so you have something like this. So if it is equal to 5 Ether, it's not going to revert. But if it is lesser or greater than 5 Ether, it's going to revert. It's going to revert. So this is what we can do. We can easily make sure that, okay, message.value is equal to 5 Ether. Else, it should revert. So this revert means that it's going to fail. It's going to return error. So let's try to do that. So if message.value is equal to 5 Ether, it's not going to do anything. Else, it should revert. It should fail. So let's deploy this contract and see how it works. Actually, there are a lot of better ways to write this same code, which we'll be learning later, but this is just a very simple way to understand it. So let's come here. Since we are taking an argument, so we are going to be required to put that into the goal. So let's put something very big. Let's now transact. So we have it already, and the contract has been deployed. So we need to deposit. So the moment you click on deposit and check this log, you can see that it's failing. And that's because the amount we are sending is not equal to 5 Ether. So let's try to send 5 Ether and see how it will work. So I'm going to change the value from this place to 5 Ether, then scroll down, then do deposits. So let me check the log. you can see that it is successful, and we have 5 ether here. So that's because of this condition that we had there, that if message.value is equal to 5 ether, it should do nothing, but else it should fail. And let's go and try maybe 4 ether or something so we can prove that it's working. Let's try to deposit. It's going to fail. Can you see that it failed already again? So that's how to do checking in your smart contract. But let me show you one thing. Actually, this same condition, you can write it as something like this. If message dot value is not equal to
Hello, sir.
5. Hello, I'm with you.
I don't get what you're saying, because your screen, the screen that I can see here is just showing one thing. There's nothing going on the screen. But you're saying that you're deploying contracts, but I can only see UNT 256 public immutable goal. You're not writing any code. It's just stagnant. Or
Okay,
are you not showing your screen?
is that applicable to you alone or other people? If
I
you
don't know.
if you, if you have the same
We can
problem,
see your screen clearly on our end.
okay, you can see my screen clearly. I feel like maybe it's your network, but you should zoom out. Maybe you've zoomed in too much. Do you get?
Okay, no problem.
So if message of value is not equal to 5 ether, if it's not equal to 5 ether, then it should revert. But if it is equal to 5 ether, it should do nothing. So this code you are seeing here is equivalent to what you have here. Is equivalent because if message of value is not equal to 5, that's when it should revert. But if it is equal to 5, it should do nothing. There's no else statement. So it's just only the if. So you don't need the else, and that's good. So you can easily eliminate the need for the else. That's one thing. And also another thing about revert is that we can also set message in your revert like this, that okay, value is not 5 ether. Okay, you can say the value received is not 5. The value received is not the received value. Okay, let me try. The value received is not 5 ether. So that's how it works. And let's try to deploy this contract again. Let's scroll. Trust, can you see my screen now? Hello,
Yes, I
Trust, are you
can.
there?
Yes, I can. I can.
So
Thanks.
let's do 5. Let's do a very big number, which is our goal, and let's transact. The moment you transact, it's going to deploy the contract, and we can say click on deposits. It's going to fail because the value is not 5 ether. So let's try to deposit 5 ether and see. 5 ether, right? Deposit is now working. We can achieve the same result. But there's a problem with this contract again. The moment we hit our goal, we want to stop accepting donations. So the moment we hit our goal, which is this goal here, we should stop accepting donations. How do we do that? We can say if progress is equal to goal. That means the moment our goal reach our progress, then that means we've gotten where we are going and we are not accepting any donation again. So that's what this one means. If goal is equal to progress, then revert immediately that goal reached or something. Goal reached. So this smart contract is going to stop receiving any funds from anyone. They meant to reach our goal. But there's a problem because the goal is stagnant, which is because it is immutable, right? You decide the goal from the beginning. You decide to go from the beginning. And one thing again is that the progress is going to be stagnant too because it's not incrementing. What we can do is that anytime someone deposits money to this contract, you are going to increment the progress. You are going to say progress is equal to the amount the person is sending, which is message dot value. Do you get? So now this is going to keep increasing. It's going to keep increasing, and we can um, we can continue to, you know, deposit, and it's going to keep showing us our progress. So let's go back to our code and let's try to deploy this one more time. So let's go here. Let's let's yeah. One thing again is that you have to be very careful with your smart contract logic. There's a bug in this code that no one is aware of right now, and I'm going to show you the first bug. Okay, let's not try the bug first. Let's try something that will work. Let's set the goal very high. The goal is very high, something very high that we know that we cannot reach at once. So let's transact. The moment we transact, we have a new donation contract here. And anyone can come and say, okay, I want to donate 5 Ether to this contract. We can do deposits. Oh, it's failing. Why is it failing? Let's check the error message, please. The value received is not 5 Ether. That's why it's low. So let's check why it's not 5 Ether. Let's try to send 5 Ether and click on deposit again. So it is now successful. You see that we are getting the error message now from the console because we added an error message to the revert function. So now the next thing is we have 5 Ether in our contract because we deposited 5 Ether. We can still come again and deposit another 5 Ether. Let's try to do that. Let's try to deposit again. So this is going to continue till we reach our goal. What's our goal? See, this is our goal. What's our progress? You see our progress. So we are still far behind our goal. So it's going to keep accepting donation till we reach our goal. So one thing again is that with this kind of system in place, we are rest assured that we can keep receiving money, but there's no way to withdraw from this smart contract. And we notice that our fund is reducing every time. There's no way for us to withdraw back our fund because there's no withdraw method in our smart contract. We're going to add that one later, but let me now show you the bug that I was trying to explain the other time. The goal of this smart contract is 100, right? 100 way. Let me transact. I am here right now. If I click on goal, you can see that the goal is 100, but the minimum deposit that you can make into this contract, it is 5 Ether, and there's no, exceed the value. So there's a contradicting statement. You have to contradicting statement. This one here now, you cannot contradict this one. So that's what is going to happen. Let's prove it. If I come here and say deposit 1 Ether, no, deposit 5 Ether, sorry, 5 Ether, then click on deposit. It works. Yeah. It works, yeah, actually, because according to logic, progress is equal to go. And at the first time, it's the progress is not equal to go. It is there are a lot of bugs in this smart contract actually. Okay. This contract is not going to work. Basically, that's why you have to be very careful with smart contracts. Now, I will tell you why it's not going to work, but let's take everything a step at a time. We all understand this line 18, right? That the moment is not 5 Ether, it's going to revert. The only problem we have now is this line 22. Now let's try to do progress. See, this progress now, it is very, very bigger than our goal. It's far ahead of our goal. That means we've reached our progress, and we've reached our goal, and we've exceeded it by, a large amount of value. So what we can do now is to come here, and say, let me show you something. Let's try to deposit again. Let's try to deposit 1 Ether again, and click on deposit. It's not going to work. So because the minimum value is 5, let's try to deposit 5. Let's click on deposits. It's not working again. It's not working. Let's try to change the value 5 Ether. Scroll down and click on deposit. You see that it's working, and the amount you have on this balance is on this contract is 10 Ether. And this is not the desired effect that we want. We want it in such a way that the moment we exit our goal, we should be able to stop receiving funds. So the only mistake we made right now is that on line 22, we added is equal to progress is equal to goal. That means for this contract to stop working, the progress must be equal to goal. If it is greater or lesser, it will not stop receiving funds. So to patch that error, we can say the moment that the progress is greater than or equal to goal, greater than or equal to goal. Sorry, greater than or equal to goal. So the moment progress is greater than or equal to goal, then you should revert. So this is the correct way, because the moment let's assume our progress is at, let me comment out, our progress is at 100, then our goal is 200. Do you know that the contract we keep on receiving fund because we've not reached our goal? But the moment to reach 200, it will stop receiving, and from that moment, it's going to stop throwing error. And if you notice, we are wasting a lot of ether. So the best thing we can do is just to reduce the minimum deposit, maybe to 1 ether. So what we can do is reducing it to 1 ether. Then we can also come back here. Let's delete. Let's set our goal to maybe like a very big value. Let's transact. We've transact, as we've we've deployed the contract. The next thing now is for us to now click on deposit. Let's deposit 1 ether. It's going to deposit, it's going to work, and you can see that we have 1 ether in our smart contract. If you try to click on goal, you can see this is our goal and this is our progress. Our progress is far ahead of our goal, and if this our logic is working, we should at this moment we should stop receiving fund. So let's try and deposit under 1 ether and click on deposit. You see, it's going to fail. And if you check the error message, let's go and check the error message. Yeah, you can see the error message. The transaction has been reverted to initial state. Reason by the contract is that goal reached, which is this one, that our goal has been reached. That's why it is reverting. So that's how to use revert and if. So another thing you can also use if for is maybe we want to return a particular value. Maybe is it something like this? We've done something like this in our first class, which is function. You can have is greater than goal, or is goal exceeded. Let's have a function that checks if goal exceeded. This function is going to be internal because you don't need it off chain. It's going to be internal function. Is goal exceeded? And what this goal exceeded does is that it checks whether the goal has been exceeded and it returns true or false. So returns bool. It's going to return bool. And for us to do that, you can say, okay, if progress is greater than or equal to goal. Let me try to ask please so I can understand very well. Is greater than or equal to goal. Return. So sorry, is this goal that we are meant to use? This one is the state variable. So you can say return true. Else, which is the else block. You can say else. Return false. But one thing is we have to make this one view function because we are not changing anything inside it. The view function. That's why it is complaining. Is goal exited? So the purpose of this goal exit is to check for us whether the goal has been exited or not. So what we can now do is that we can easily replace all this block of code, and you can just say if goal is goal exited, then revert. It's going to revert with what? A message, goal exited. So that's how it works. So we can easily return true or false. When it is true, this is going to return true or false. When it is true, it reverts, and it's just a way to like modularize your code. And another way is we can also do one thing again with this our contract. We can have another function that also withdraw. So function withdraw. Then you know how we do that already, right? It's going to be a public function, and The moment you withdraw, it's going to send the funds to you. How do you now check who is withdrawing? So the best thing you can do is that anytime we deploy the contract, we have to specify who can withdraw. To do that, we need to specify a state variable, address, owner. And this owner is going to be a payable address because it's going to receive funding. So let's say owner, then owner is equal to whosoever that deployed the contract. So there's an error. Why are we getting this error? Can someone tell us? Please unmute.
Message.sender is not payable. It's not a payable address. You have to wrap it with the payable keyword before you can use
Thank
it. Yeah.
Yeah, thank you very much. That's correct. And it's because we didn't wrap it with payable. So that's the payable. So meant to wrap it with payable, it's going to make it it's going to convert this message or sender from address to payable, and it's going to work. The next thing is withdraw now. For us to withdraw, anyone can click on withdraw. You can say owner dot transfer. You want to transfer all the amount in this, all the fund in this smart contract. You can say address of this smart contract dot balance. So every amount in this smart contract is going to be transferred to the um, owner. All the money inside this smart contract is going to be transferred to the owner using this method owner dot transfer. Then get the amount in this smart contract and transfer it. Let's now deploy this contract again and let's see what we have, because we are progressing a step at a time. Although it might seem difficult, but we are progressing. Let's say our goal is something very small. Let's transact. We have a new contract with 4 interface. We have the goal, we have the progress. The progress is 0. Let's try to deposit 1 ether, because the amount we can deposit is 1 ether. Anything below or greater than that is going to fail. So let's say deposit. We deposited and the balance is now 1 ether. And if you click on goal, you can see that the goal is constant, but the progress has increased to 1 ether. Let's now click on withdraw. You can see that the money has been withdrawn from this account back to the owner's wallet. So that's how it works. And if you try to donate to this contract again, let's try to donate. Let's try to deposit, sorry. It's going to fail because we've exceeded our goal. And that's how to write a very simple crowdfunding smart contract, a donation smart contract. This is how this works very well, and you can deploy it. Yeah, you might actually need to audit this code a bit for you to be sure that there's no error or any bug in this code. But this is something you can use to practice and write a very simple smart contract for your friends to donate to you, or if you have any targets. But one thing is that this revert and all this revert, assert, and require, they work almost the same way. They work very similar. Now let's do something like this. Let's try to use revert. See, revert, instead of having all this block of code, you can actually use revert to simplify everything that you are doing. In fact, sorry, you can use require, sorry, not revert, require. Copy this condition and put it in require. And that's all. That's all you need. You don't need this code again. The same with this one too. You can say require that if goal is exceeded, true. This one is true. Okay, not goal exceeded. So not. Let's say this one is this. That's just different, and we are good to go. You can see that this multiple lines of code, we've been able to concatenate it into just one line, and that's the power of require. And let me now explain what this require does so that you can understand. Require takes 2 arguments. The first argument is the parameter, which is compulsory. Sorry, the first argument is the condition, which is compulsory. The other one is the error message. So now you can say comma, then if the condition should fail, then you should print out the error message on the screen. So initially, what we are doing is that whenever we revert, we show an error in the console that, okay, the value received is not 5 ether or 1 ether or any amount that you specify. So you can copy this error message and bring it here. Now, we have to specify the condition that, okay, if this condition is not true, then it should revert. What is the desired condition? the desired condition is what we are concerned about. Desired condition is that message dot value must be equal to 1 ether. That's our desired condition. If you are not getting this desired condition, you'll be getting this error message. That's how require works. So you can replace this with just with this simple line of code, and that's the power of what require. And require is far better than using revert in many ways, which you can do research online in terms of gas and the likes. So another thing again is that you can also replace that one with this same thing. You can say require that is not goal exceeded. So that's the desired condition that, okay, our desired condition is that the goal must not be exceeded. That's the desired condition. If the desired condition is not working, then what should be the error message? This should be the error message on screen. So that should be the error message on screen, and that's what we have to work with. Okay, we are done. Let's try to deploy this contract. You see that this one looks a bit neater than what we have before. And let's go back to our deploy and run transaction tab. And let's try to set our goal to maybe like 1,000. Let's transact. The moment we transact, we can see that we have all those interface up. The next thing is that let's put the value of ether that I want to donate. Let's click on donate. We have 1 ether and it's working perfectly. Now, if you try to donate 2 ether, let's try to donate 2 ether, and let's click on deposits. It's going to fail. I'll go and check the error message. It's going to show the value received is not 1 ether. You see, that's the purpose of the check-in using require. Let me now try to donate 1 ether. You know, the value required is 1 ether, right? But the goal has been exceeded at this point. If I try to deposit again, it's going to fail again because goal exceeded. Although it means the first requirement, it doesn't mean the second requirement. And that's the power of what require. So it's just like you are setting a requirement for your code to execute. So if this should fail, everything under it is not going to execute. If this should fail, everything under it is not going to execute. And because the blockchain is transactional, everything will be reverted back to the initial state. So you're not changing anything on the blockchain. So don't worry that you are changing anything on the blockchain. You are not modifying anything. If your code should fail, it's not going to modify anything on the blockchain. It's going to revert back to the initial state. So that's how it works. And from here, you can do a lot of stuff and build amazing solutions and stuff like that. Then another thing again is while loop. While loop in Solidity is not advisable because for every loop that you make, it's going to consume gas, and if your loop start getting too big, you're going to consume a lot of gas. That's one thing you have to know about using loop in Solidity. Second thing is that there's nothing like switch case in Solidity, and in the slide you can see that it was just cited as an example that you can get in other programming language. That okay, in other programming language you can see switch case and stuff like. But in Solidity there's nothing like switch. You only have if, else, and else if. So those are the things that we have, and when you get to them, you can easily check that. And what we want to do next is we want to build a simple voting system. So I'm going to provide this code on GitHub so that you guys can have access to it and practice. Let me check if there's any message. Okay. There's no message from anyone. So let's do this. Let's try to build a voting system. This is very similar to what Thank ARB is doing. So we have 16 voting.sol. In this voting system, we have a very simple rule. We have the admin. We have which is the role of the admin is just to add new voters and give them voting power. The admin can also remove them. So I'm going to like add you to my voting system, but if I feel like okay, maybe you are not doing what I want, so maybe you are just spamming the system, then I can remove you. I can remove your voting power. Then we can also have different proposals on going on that a delegate can vote for. So as a delegate, you can vote for any proposal that you want, and you can specify the amount of voting power that you want to give to that particular vote. So now let's just copy this. Let's copy this, and let's do this. Let's have voting contracts. Okay. So as I've mentioned before, we're going to be having owner. So it's going to be an address. We are not dealing with any transfer of funds. It's just voting and voting alone. So what we need to do is just to see whether um, a particular decision is going to pass or not. So what we do is that we have address of the owner. Then address of the owner is going to be immutable because we don't want to change the owner. The owner is just a single person. The next thing we are going to do is that we are going to have a struct, because the struct is going to represent each voter. So in the or each delegate, you can call it delegate or voter or anything you want. So in this delegate, each delegate have their own address, which is the address. You can just say address of the address. You can name the address account or stuff like that. Now the next thing is apart from the address, we also need the voting power. So you can add that one in units, voting power. So that's going to be a particular value. The next thing you can also have is we can have something like what other thing do we need to do? Okay, let's just have that for now. Those two is enough, so I don't get this too complicated. Then the next thing is we're going to have another struct for proposals. You can name it proposal. A proposal is going to contain a string which is going to be like the description of the proposer, that okay, what is this person proposing? Then we're also going to have the address of the person that is proposing this particular information. Then also we are still going to have other minor information regarding that. Maybe the votes. Let's say you're in 256 votes count. So now the vote count is just going to, okay, this proposal, how many people voted for it? How many people voted for this proposal? So we have just three things describing this proposal. The description of the proposal, which can be like a link or maybe a text or anything that can let delegates understand what this proposal is all about. Then the next thing we can also have, we can have the person proposing the particular proposal. We can also have whether this proposal has been executed or not, or maybe it failed. So let's say bool failed. A proposal can fail. Maybe it doesn't get up to the numbers of votes that it is required for it to pass. Then the next thing is also like maybe it has been executed. When it has been executed, that means it has been carried out. So you don't need to like worry about it again. So by default, okay. So this, instead of using fail, let's use success. Or let's use past. Yeah, instead of making it fail or any other thing. The main reason I'm doing it like this because by default, solidity is always initialized to false. So when you say solidity is always initialized to false for Boolean values. So when you say fail, that means it is going to be like false by default. So which is not what we desire. What we desire is that by default it should be the path should be failed. So that's what I really mean. So it's just like naming convention. Like by default, this proposal has not been passed. So it's going to be failed. Next thing is, how do we now represent each vote and each delegate? For us to do that, we need mapping. This is where mapping comes in. This is a structure, like it's like a struct. A struct is like a description of a particular entity or like a new data type that you're trying to formulate. So although you formulated the data type, you still need to use it in your code. How do you use it? By having a mapping or by using it as values or stuff like that. So for mapping, you can have a mapping of the address of the delegate to the particular delegate. Then we can now say it's like a mapping of delegates. So this is going to map address of each delegate to their information. So you can also have another thing like maybe status, bool, status. There are times we want to remove delegate or stuff like that. Maybe the delegate is no longer active, maybe the delegate has been removed or deleted or stuff like that. So this is just going to be the status. If by default the status is false, so everyone is false by default. If you try to check, it's going to be false by default. So we need a constructor so that when we deploy this contract, we can add the owner by default. So we can say address of the owner. We can append an underscore after it, and you can do this by saying owner is equal to owner underscore. So which is really awesome. So we've been able to set our owner by default. Next thing is we need a function that will allow the owner to add delegates to the contract. So you can have it add delegates. So for you to add delegates, you need just two things. You need the address of the delegate you want to add and the voting power you want to give the delegate. Address of the delegates that you want to add and the voting power, which is in 256 of the voting power. So that's it. Then it's going to be external function. It's going to be external. It's any other thing is not really, because it's going to modify the state of the blockchain, so we cannot make it pure view. So what we do now is that we now come here, we get the index of the delegate. But before we do that, see, please note that this can lead to security problem. How do we ensure that the person calling this function is actually the owner and not someone else calling it trying to add delegates? But also that we have to do some checking, and that's where control and error this thing comes in. So you need to say require that the message.sender, the person calling the particular function at this time, is equal to the address of the owner. Else, send a message that okay, you are not the owner. So that's how it works basically, and we are getting an error message. Okay, don't worry about that for now. It's just telling us about immutability and stuff like that. So now, once we confirm that this person is actually the real owner and is not impersonating or stuff like that, the next thing is proceeding with the process of adding the delegates. So for you to add the delegates, you have to know the address of the delegate you want to ask. Maybe just make it an index, because it's a mapping of the address of each delegate to the delegate information. So you can say it's equal to delegates. So which is this delegate here. This information here, this structure. So how do you now build this structure? You build the structure by passing all the necessary arguments. You can say delegates. This delegate here, comma, the voting power here. So then also comma the status, which is now true, because adding the person, it must be true by default. It must be active. It must be valid. So this is how we are going to add a new delegate. And another thing is that we have to keep track of the list of delegates that we have, but we are going to do that one later. But let's try to also add another function. The function is going to be very similar, both in everything, but this time around it's just going to be function remove delegates. So what's the process of removing a delegate? The first thing you have to remove a delegate, you have to set the status to false and the voting power to 0. So delegates, comma, in 256, voting power, then external, which is an external function. So then we can now see that who is calling this function. It must be the owner that is calling the function, not just anybody. Anybody cannot just add a delegate. So that's why we are using this require. Then the next thing is we have to do the same thing now by saying that, okay, underscore delegate, which is this delegate here, which is a mapping delegate, then add delegates to it, add delegates, then it's equal to this delegate here. But this time around, we are setting the voting power to 0 and we are setting the active status to false. Then we don't need this argument again. So we just have only the delegate. To remove a delegate, you just need only one thing about the delegate. You need the delegate information, just the delegate address. Then also you can do something like maybe delete delegates. So you can also do something like delete delegate, which is going to delete the index of the delegate instead of going through all this stress. So that's another way of removing delegates. So it's just going to be like almost same thing. And let's move forward. Let's try to do one more thing before we deploy. Let's try to backtrace. And if you notice that this line 37 is repeating everywhere. It's repeating here, it's coming here, it's coming. So instead of trying to have it's repeated over and over and over, we can use a modifier. That's where a modifier now comes in. A modifier comes in by saying what? I'm a modifier, right? So let's have the modifier. And you know modifier is owner. So now what this does is that it checks whether it is the owner or not. You know, the modifier comes in two parts, the pre function and the post. So this is it. So now what we do is that we now copy this line here, we cut it and paste inside the modifier. So this modifier is going to be what we are going to be using everywhere instead of repeating the same line of code everywhere. You can see I added it to the pre, not to the post, because I want this modifier to evaluate before the function runs. So that's why if you want something like maybe you want the modifier to run after the function, you can also have it like that. There are cases like that. So let's move forward a bit. And how do you now use this modifier? By saying that by appending this thing is owner to this place. You see that I've appended it as a modifier after it, so it's going to be the same thing. Then I can also remove this line 40, save it, and add is owner to it. By doing this, you can really change the behavior of this function in such a way that if it is not owner that is calling this function, it's going to fail. Let's now deploy this code. You see the power of a modifier, and that's why I said you need to attend this class, because everything that you've been learning, this is where you will use it and know the real world application of everything. So now we have this function, this voting contract 16, and we can specify the address of the owner. Who do you want to make the owner? I want to make myself the owner, so let me just copy my address and paste. So let me transact, and it's successful. You can see there is we have two functions. We have the add delegate and we have the voting power. Let me try to add this account here, this second account, as a delegate. I can just come here and say add as a delegate and give it 100 voting power. So I'm going to transact and it's successful. Oh, is it successful? Oh, sorry, it failed. You know why it failed? Because I'm not doing, I've switched my account. So let me switch back to the normal one. Sorry, let me try to transact now. If I transact, you can see that it's working and it's showing me a green check mark. That's because it's successful. So if I go up now and I try to add the delegate again, it's still going to work because there's no check preventing you from adding the same delegates multiple times. So it's just like overwriting what you have already. So there's no check. So we need to like modify this contract and add those logic too. But the moment we switch these accounts, maybe to another account, let me switch to another account. You see that I've switched to another account. Let me try to add a delegate. It's going to fail. You see that it's failing. This red cross mark, and it's showing that you are not the owner. So the same effect that we could have achieved by having that require everywhere, we can just use a single modifier to achieve it in thousands of places throughout our smart contract. So that's the power of a modifier. And if you have been wondering that, oh, what's modifier all is about, this is what modifier is all about. Inside the modifier, you can have complex conditions and evaluation that evaluates different logic. Let's go back So let's try to remove a particular delegate. So let's try to remove a particular delegate. Let me paste the address and let me say transact. If I check, it's going to fail and it's going to bring an error. You are not the owner. So the modifier is working for the remove delegate too. By scrolling up a bit, I can easily switch back to my original account, which is the one with the 67 ether. So let me come here and click on transact, and you can see it is working now. The delegate has been removed successfully. So that's the function of a modifier. And you can use it anywhere in your code. If you have any question, please feel free to drop because we are moving really, really fast and everything is becoming clearer now. How to use modifiers, how to use structures and the likes. So we've been able to use this simple structure, but I mentioned something earlier that we have to check whether this someone you are trying to add is already a delegate before adding them, so that you won't be adding a delegate multiple times, overwriting the existing one. You can just say require that this delegate here that you want to add dot status is not equal to is not true. Yeah, is not true. You can say is not true. If you have worked with any programming language before, you should know that this is not true. Or you can also say something like this equal to true because desired status is equal to false. Sorry, that the delegate status must be false before they can be added as a delegate. Because when your delegate status is true, that means it's been added already. That's why the desired state is false. So that's why we have it in the require that. Okay, we require that the status of the delegate must be false. So, and also the same thing you can say is not equal to true. All these things are the same thing. They are just syntax. They all work. But the best one for this scenario is by saying not, adding not in front, not delegate status, which is that means it is not true. So that's the best approach to use by with this. And if you are confused about this, it's actually something very simple, and you can reach out to the technical team to help you with that. Now, so you can just say you are already a delegate. So you don't need to stress yourself about trying to ask someone that is already a delegate. So you can also copy this line of code again and bring it here. But this time around, for you to remove someone, their status must be true because you must be a delegate before they can remove you. So the required status is that the status must be true. So if it is not true, then you should return an error. You are not a delegate. So that's how it works. And basically, that's the logic behind our code. And it's as simple as ABC. So if you have any question, please unmute and ask now before we proceed. Hello? If you have any question, please unmute and ask before we proceed.
Hello, sir.
Hello,
Am I
good
audible?
morning. Yeah, you're
All right,
audible.
good morning. This is Sam. Yeah, so for contracts like this, like writing a contract, a voting system, how should we approach it in the sense that should we first of all think around all the conditions, all the things that need to be in the contract before we start writing the contract, or as we are developing the contract, the conditions will start coming to us, then we'll start implementing it. I mean, regarding all the conditions, all the things that need to be in the contract.
Okay, you have to plan ahead. That's it. You have to plan ahead. But there are times maybe you forget to ask something, so you need to just plan ahead. That's one thing about smart contract. Another thing again is that there are times whereby maybe you omitted something, you have to put it here. Then you have to also do auditing. So from that auditing, you'll be able to like have more insight on what could be wrong with your code. Yeah. So that's it. I hope I've been able to answer your question. Any other question before we progress? Now you can see that we have this method already. Remove and add delegate. Then the next method is voting, or let me say submit proposal. Let's add submit proposal. Anyone anywhere can submit a proposal. So function submit proposal. For you to submit a proposal, let's go to the proposal um, structure. You need three things. You need the description, the person proposing it, the vote count, and if it has been executed by default. But one thing is that the only one we really worried about is this description, and you will see later on now. So let's just have string memory description, and we can have external, right? Then it's like this. So now you can see that we don't have any mapping to store our proposal. So we need to find a way to store our proposal inside the mapping, because we have a lot of proposals, just not a single proposal. We can have U256 and of mapping to proposal, because each proposal is like an ID. So each proposal is going to be like an ID. So it's going to be proposals. Okay. Now you see one thing is that there's no way for us to know the length of a particular mapping without keeping track manually. So I'll show you what I mean later on. So let's do something like that. Now proposal, then the index of the proposal. Let's say it is index 1. But how do we know the index? How do we make it dynamic? There is no way. We have to keep track of the index manually by having something like maybe uint 256 and say proposal count. So the number of proposal we have on this thing is going to be equivalent to the number of proposal here. And you can easily increment it anytime you add a new proposal. You can just come and say what? Proposal count plus plus. See, anytime you add a new proposal count plus 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 plus. Anytime you have a new proposal, just come and add and increment it, because there's no way for you to know the length of a particular mapping. You mentioned it that there is no way for you to call the proposal.length method on the listing. There's no way for you to call the length property on this. There's nothing like length. There's nothing like anything on this proposal. So the only way for us to do is that by using that trick, by keeping track manually. So proposal, this thing now, you can say proposal count, which is this one. Proposal count. Then you can say is equal to a proposal. Then inside the proposal, I have the description, which is this one. What other thing do we have? Please, you guys can unmute and tell me as we are going. Description, what other thing again? We have the person proposing, this is the proposer. We have the vote count. But one thing is that the proposer is the person calling this function. So it's going to be message.sender by default. You don't need to worry about that one. Then the next thing is the vote count. By default, the vote count is 0. Every other thing is false, false. It has not been passed and it has not been executed. So it's going to be false, false. That's why it is false, false. Let's save it and see what we have. There's no error on the screen. So we are good to go. Anyone can propose, and the moment you propose is going to increment. Then we want to make this proposal public in such a way that we want everyone to be able to access those proposals and by index. So we can add public to this proposal. And let's go and check what we have now. Let's go and check our new contract. So we come here, we try to deploy. Let's get the owner address. I'm the owner, so I'm going to use my address. So let me try to, let me try to decrease. I'm trying to paste that file. I don't know what's wrong. I can't paste anything in my remix. I have to refresh, sorry. Okay, we are good to go. So now let's go back to this our contract. Let's go to this voting.sol. We have all the contracts here, and you can see that it's getting a bit too long, but don't worry, we are getting there. Now let's try to do something. We can do that by, if you notice, anytime you refresh your remix, it's going to reset your virtual machine and it's going to reset all the data balance. So don't worry, you still have all your contract. Just save and it will compile again. So let me copy my address and try to paste it here. Transact. So I've been able to transact now. I have a contract here. So we've tested every other thing. We've tested the remove delegate and add delegate. So let's try checking proposal by index. Let's say we have proposal 0 now. Let's try to call it. You can see that in proposal 0, everything has been initialized. And that's why um, we said mapping is like hash map, where all the value have been initialized by default. If you try to get index 1, it's not going to complain. It's just going to return default values. So that shows that it does not exist at all. So that is one thing about mapping. Unlike array, if you try to get an index of an array that does not exist, it's going to throw error. So please take note of that again. Now let's try to submit a proposal. Let's make it hello world first proposal. So you can see transact, and the moment we transact, it went through because there's no check-in, there's nothing literally stopping us from submitting the proposal. Let's now try to get index 0 and call. You can see that index 0 now has what? Description, the proposal, and all those stuff. Try to get index 1. Index 1 is still 000. So that's how to submit a basic proposal. And this proposal is now on chain. So how do we now vote? How do we vote on each proposal? For us to vote on each proposal, you can say function, then vote on proposal. So which proposal do you want to vote on? You have to know the ID of the proposal you want to vote on. You can say unit 256, which is this. Unit 256. You can say the ID of the proposal, or you can say proposal ID, comma, with the unit 256. Oh, sorry, let's just have it like this for now. You can also external, then since you have to be a delegate before you can vote, right? If you are not a delegate, you will not be able to vote. So you have to do some checking. So let me copy this code and say require that the message.sender is a delegate, right? How do you know someone is a delegate? By checking the delegate mapping, delegate ms.sender dot status. So if it is true, desired status once is true, and you don't need to do anything further because delegate message.sender dot status. If it is true, then we know that you're a delegate. But if it is not true, you are not a delegate. So if you notice one thing is that this part of the code, and it looks a bit similar, but because this one is a bit dynamic, this one is static. So don't worry. We can use a modifier for that one later. If you feel like you can, there's a way you can use modifier for it. You can use modifier to reduce the repetition. So vote on proposal. How do you vote on the proposal? So you have to get the proposal ID. Proposal, then the ID of the proposal that you want to vote on. Now say dot, what do you want to modify? Dot vote count. Dot vote count plus is equal to your voting power. Because whenever you vote based on your voting power. So how do you get the voting power of this delegate? It's by saying underscore delegates message dot sender dot voting power. So we are going to append the voting power into the number of votes available for this proposal. But there's a problem in this our smart contract. If a particular person can keep coming back, voting every time. So we are going to prove that, and we are also going to see how to prevent a particular delegate from voting twice on a particular proposal. So let's save this and let's try to deploy. Let's remove our former contracts. Then I want to do one more thing. I'm tired of pasting the owner every time. So instead of having a parameter like this, we can just remove this one and make whosoever that deployed the contract to be the message of sender. So you get me right? So let's do the transacts and we are good to go. The contract has been deployed. We don't have any delegates yet. So let's try to add a delegate. Let's switch accounts. I'll switch to the second account. Let me copy the address and paste the address of the delegate. Then I will say 1,000 voting power. Then I can now say transact. Oh, what was that? Because I've switched my account, so I won't be able to add because I'm getting an error. You are not the owner. I've switched the account, so I have to switch back to the default account, the one with the owner permission. Let me transact, and you can see that it is going through now. So it has been added as a delegate, and you can also add another person as delegate. Let's try to add another person as a delegate. Oh, but before we do that, let's try to add the same person as a delegate again and see whether we get error. Because we added that you cannot add the delegates twice. Let's try to transact. You can see that we are getting an error, and we can see that you are already a delegate, so it cannot be added again. So that's the purpose of the checking we made the other time. Let's try to copy another account and paste that one. Let's give this account 500 voting power. We can say transact. You can see that there's an error, and the error is because I didn't switch back to the account with the owner's permission. So I have to switch and say transact, and now it's working perfectly. So we have to delegate, and these are our contracts already. Let's now try to raise a proposal. Let's try to submit a proposal. The name of the proposal is Hello World 1. Let's transact. Because I've made a transaction, let's make another transaction again. Let's name it Hello World 2. Transact again. We have 2 transactions already. Let's check all the proposal we have. Proposal 0. Let's call it. You can see what we have on the screen. Hello World 1. This is the person that proposed the proposal, and every other thing is on the screen. Let's check 1. You can see it's Hello World 2. So that's how it works. Let's try to vote on proposal 1. If I try to vote, it's going to bring there because I'm the owner, but I'm not a delegate. I cannot vote. Let's transact. You see, it's showing error. You are not a delegate because I'm just the owner, I'm not a delegate. I cannot vote. So let me switch to a delegate account. This guy is a delegate. So let's try and see whether it can vote on proposal 0. So if you vote on proposal 0, you can see that it went through. There's no error. Then we can call on proposal 0 by calling this. And you can see that we have a vote count 100. Yeah. Then, but one thing, because of the way we wrote our smart contract, there is no checking. So this guy can keep on voting. Multiple. Can you see I'm voting every time and it's not checking. So if I call now, you can see that I have about 22,000 votes count. So to prevent that, we have to find a way to track who have voted on a particular decision or stuff like that. To do that, we can come here and have a mapping inside the structure. A mapping of voters. So a mapping of address to bool. So this address is basically going to store like the address against whether the delegate have voted or not. Do you get? So you can say voters. So this is how it works. And as from this moment, henceforth, you can save. But when you save, you run into different problems. And that's because you cannot have a mapping inside this particular function. So we need to do one thing. For us to be able to do this, we need to copy this proposer into storage. So you can just have like this and say, so we're going to use a storage. Let's say, um, what is the proposer? I can say this proposer is a type, right? Type, proposer type. It's like saying you in 256 proposer, because it's a type, it's a custom type. So proposer, then store it inside storage, then name it proposer. It's like saying string memory description too. So that's just the same format. You can say it's equal to this proposer here, this one here, right? You can copy it and say proposer, then proposers count. So by doing this, we are moving it into storage. And let me show you something. Without this now, we are going to run into a problem. See that there's error. We need to put mapping here. Mapping. Can we put mapping here like this? See, it's not going to work. It's not going to work, actually. You see? It's not going to work. You cannot say message dot sender then 0. It's not going to work. There's no way for you to declare mapping inside this kind of situation. So the only thing you can do is by avoiding it all together. So if you want to avoid it altogether, you can use this approach by storing this inside a storage. You've copied the value, and also it's like there's something called reference and value. This is a reference to the particular proposer. So you don't need to worry about that now, but just so that this is the only way you can achieve that, you can say proposer, this proposer here, dot, what do you want to set? Description is equal to description is equal to description. This description that we have at the top. So it's going to work, and every other thing is not going to like be initialized. So you need to set the proposer to the person proposing it. You can say proposer dot proposer is equal to message dot sender. So with this approach now, you can easily ignore the value that you did not set. Like we are not setting vote count, we are not setting passed, we are not setting executed, we are not setting all these votes are by default. So everything is just there right now. Everything is just there, and it's there, and it's working. So that's basically, and it's going to modify this particular um, value. So by doing this, anytime someone votes, because you have a mapping here now that can easily keep track of those that are voting, you can say that okay, proposer ID inside this vote on proposer. Then, we have a mapping inside this proposal, right? We still need to reference to it by the name of the person voting. The person voting is the message or sender, right? It's like a nested, it's like a two-dimensional array, but it's not like it. We have to like reference to the proposer, then reference to the voters. So it's equal to this value, which is true or false, because we voted. So the only thing we can do is just true. Make it true. Then let's check this error. What error are we getting? Okay. Let's try to check the error. Sorry. What error are we getting? Index has to be type, mapping or struct is index, blah, blah, blah. So let's try to solve that problem. For us to solve that problem, we have to still use the same approach that we used earlier, which is copying this into storage. So you can just do something like this. Let's do something like this. Let's say proposer storage, then proposer, which is a new variable that will be declaring, is equal to proposers. And we have this, which is the proposer ID. So let me say proposer ID. You save this, and you can say proposer dot. Let's remove this. Proposer dot vote count is equal to this. Then this one now, instead of having this long, you can say proposer message dot sender is equal to true. What's this? We are getting a particular error. Let's try to scroll up and check what could be wrong. Oh, sorry. It's going to be dot voter, sorry, there's voters there, dot underscore voter. Do you get? That's why we are getting the error basically. So that's how we're getting the error. So we've been able to solve that problem now. So no one can vote twice on a particular proposal anymore. I'm going to test that one later, but let's move on to the next thing. We can also move a bit forward and see whether we can set quorum. So now, let's say for every proposal that we have, the quorum should be like 10,000 votes. Or let's say should be 2,000 votes. You can just declare a particular in 256 quorum is equal to 2,000. So for us to reach quorum, for this thing to be able to execute, we have to like get 2,000 votes. We can have function execute proposal. Then you have what proposal do you want to execute in 256? The proposal ID. Then you can say external. You can also have it like this, that okay. Get the proposal. Only a delegate can actually execute a proposal on this kind of system. Let me copy. Let me try to paste. Only a delegate can execute, but if you still want to make sure anybody can execute, just ignore this line. So then you can comment it out. So if you want everyone to be able to execute. Let's now move forward. The first thing we have to do is because we have to check whether this current proposal that I want to execute has reached quorum. So the only way to do that is by coming here and say, let's paste this. Sorry, let me copy this. Let's paste this code again, and let's see what we have. So we have the proposer, storage, blah, 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 blah. The next thing is we can now say, okay, we can actually say, we can store this inside memory instead of storing it inside this. Let's check it. Okay, it's only valid in storage, so you cannot store it inside memory. That's another thing you have to know. So if proposer dot vote count is greater than quorum, that's when this thing should execute, right? Else it should fail. So we can use require for that instead of using if. You can say require that vote count is greater than or equal to quorum. If it's not equal to or greater than quorum, then you have not reached quorum. So that's just how it works basically. Next thing again is that you can also move forward and say require that apart from that, has it been executed already? If it has been executed already, so there's no need to execute it again. So you can just say proposer dot, we have just 8 minutes to go. Proposer dot executed. If it has been executed, there's no need to execute again. If proposal has not been executed, that's the desired status. We don't want it to be executed by the time we want to execute. So until it's not executed, then you can now have an error message that okay, it's proposal has been executed. So that's what you have for this thing like that. Then the last thing is proposer. You can now say proposer dot passed is equal to true, because if proposal has been passed like that, the moment you execute them, proposer dot executed is equal to true. So from this moment henceforth, if you try to run this code again, it will prevent, because the proposal has been passed and it has been executed, it's going to fail year or year. So that's one thing. So this contract is complete now, and we have a very simple voting system. And we can also, this is why we said blockchain can make voting decentralized and stuff like that. With this kind of smart contract, you can deploy smart contract on Arbitrum and ask people to, and add people that you want to become delegates and submit proposal. Maybe okay, you want to spend $500,000 on this particular project. Do you agree or you don't agree? vote. So that's how it works basically. And this is just basic of voting system in blockchain. Or this might not be really secure, but at least it's like a sample code for you to understand how voting works. So let's try to add delegates. So this time around, I deploy using the second address, not the first one. So I'm adding the first address as delegate. And I'm giving it let me give 1,000 voting power. Let me transact. It's failing because I have to switch accounts. I'll switch accounts. Let me transact. So I've been able to transact now. You can see it is working. Let me get another address. Let me copy it and make it a delegate. Let's transact again. It's going to fail because I didn't switch. So let me switch now and transact. Now I want someone to tell us how many delegates do we need to vote before we can reach quorum in this kind of system. Please, someone should volunteer and answer. Someone can volunteer to answer. How many delegates do we need to vote before we can reach quorum in this kind of system? Okay, Yusuf, you can unmute. Thank you.
All right. Yeah, I think it should be 2,000.
We need two delegates actually because each delegate has 1,000 voting power and the quorum is 2,000. So 1,000 times 2, that's 2,000. So we need two delegates to vote before we can reach quorum. Do you get?
Oh, yeah. Thanks.
Brother, hello, sir. Please, can you show the later part of the code?
Hello, can you hear me? Hello, okay, thank you very much. So the next thing is since we've deployed it now and we have this, we could have used maybe like IPFS URL, like the one we um you know taught you guys the other time how to upload files on IPFS instead of using this normal text. The benefit of using IPFS is that instead of putting like a whole document, which can be very expensive or even exceed the block limits, when you put a URL, then someone clicks on maybe like call, they are going to get the URL and click on the URL to get more info about the information. From there, you can add pictures, you can add a lot of other stuff, which is not possible on Ethereum blockchain. You can add pictures and stuff, but having a URL as the description can really help a lot and save a lot of gas fee because URL can just be like 10 or 5 words or even, 10 or 5 characters, depending on the format you are using. We are using HTTPS or HTTP or even without HTTP in the front. So that's it. Now, when you call this, you can see that we are getting a lot of info, and we can come here try to vote on this proposal. But before that, let's try to execute this proposal first and see whether we get error. Proposal 0. Let's try to execute. You can say it failed. And that's because it's going to show us the error actually. Let's check the error. You can see you have not reached quorum. So it's going to fail. So, but let's try to start voting now. Let's try to start voting. Let's start voting. Just have 1 more minute. So let's hurry up. Let's try to vote. Transact. Oh, I'm not a delegate, so I have to shoot a delegate account. Let's try to vote. Call. Sorry. Let's try to vote. We've been able to vote. So let's call on this. You can see that we have what? 1,000 vote count. If I try to vote with the same account again, it still allow me to vote, honestly. That's a bit shocking. So let's try to call it now. We have 2,000 vote count. We need to patch that bug, but so far that we have 2,000 vote count, I believe that we've reached quorum already so that we can execute this proposal. Let's try to execute. And you can see that it's not showing any error. It executed successfully. So let's try to call on this proposal again. Because it has been executed already. Passed through, executed through. If you try to execute it again, it's going to show error. And that error is going to be proposal has been executed already or stuff like that. Now, from that error that we are getting, let's try to patch that error. The error we are getting is that we didn't check whether this person have voted already. What we did was just like check whether it is a delegate. So you can say require that. Let's have this require somewhere around this place. Require that this proposer dot voter, which is this thing, is false, which is the message dot sender, is false by default. So you can say is false by default. If it is false, then we can say you have voted already. So that's going to patch that particular bug. So we can do that again by coming here to say transact. Let's transact. Let's deploy the contract again. Then let's add a single delegate. Let me add myself as a delegate. So let me paste 100 voting power, 1,000 voting power, sorry. Then let's try to submit a proposal. Let's say hello world money. So let's say transact. So we have the proposal already. Then we can now say vote on proposal. Let's try to vote on proposal 0. Let's try to transact. It went through successfully, right? If you call on proposal 0 here, you can see that it's 1,000. If you try to vote again, it should fail. The answer is failing. And the error is you have voted already. So we've been able to patch that error. So we're going to provide the full code on GitHub so that you can have access to it. And you can also check other code examples. And the best way to learn is by progressing gradually. So choose a very small task and work on it so that you can learn about how this whole smart contract works. Please, if you have any questions, you are free to drop it on the WhatsApp channel. And we're going to be having an office hour this week where you come with your code and share with the admin so that they can help you with your code. Thank you very much. And I hope you have a wonderful day. Bye-bye.